Okay, welcome to Ox Tools. I'm Tom. Today we're going to continuing on with the heavy-duty steady rest. This is the upper section here. We're going to do some milling in this area here to accept this guy here so that it can move up and down. We're going to drill through and thread the top for these bronze nuts that we made the other day for the lead screws. And then on this particular half of the steady rest, there's some work for the hinge and the latch that needs to happen. So that's what we're going to do today, some of it anyway. So let's get going and do some work and have some fun. Okay, so we got a bunch of work to do in this area. We're going to surface this, drill through, tap this. So what I want to do is I want to create some reference surfaces. I've already done this here on the split line, so I got a couple of good references there. So by putting this down on the table like that, then I can make this parallel really easily. So we can hold this a couple of different ways. We could toe clamp it down here, which is a pretty good way to go. Or we could put taller jaws in the vise. I don't know, 6 of one, half a dozen of another. Let's look at the toe clamp thing first. These are your standard mill toe clamps and T-slot nuts, etc. You know, no great mystery there. One way that is convenient to line stuff up, these grooves are generally very, very parallel with the axis of the machine. So if you have some 5/8 dowel pins that fit your slots, well, you can use those to kind of reference an edge there. And then what we would do is just, toe clamp this down here. What I'm thinking now, though, is I think I want to grab it up a little closer up here. So I'm going to do something a little different, I think. Got some bars here that are straight. Just put those in like that. And then, yeah, I like that better. We'll be clamped a little closer to the action up here, and we still have our reference surface down there, which is good. And I can change it around really easily. So, okay, I think that's what we're going to do. Yeah, looks like this thing's got a little. Oh yeah, that feels pretty good. Well, maybe I'm back to toe clamping. If there's a little twist in this thing, that's what it looks like. It'll sit down pretty good. So there must be a little twist to this thing. Something going on there. What if we go to one of these? these. Let's do that. Let's do that. I like that. Little one and I decided to go ahead and put some toe clamps on it because the those are too long. Because there seems to be a little bit of twist in this thing. I just want to pin it down a little better. Make sure I'm engaged with my reference surfaces there. There we go. I like that. All right, so I'm going to start by just decking the top of this off here. I'm going to use this end mill I got in here. I just want a minimum cleanup on this surface here. Yeah, maybe I'll do one more on that. Another 10 thousandths. Alright, there we go. That's what I want. Yeah, it looks pretty good. So I got a center line on here that I put on before. So we need that up here, and then I got to find the center this way. So we'll go ahead and move this a little bit. And you notice this has the same size shank, so I just go right in there, didn't have to take the collet out. So that's pretty valuable. All right. Okay, that's one direction. Now I want to transfer this line up on top. I'm going to darken it in a little bit. And I'm just going to use this 90-degree head here to transfer this line up on top, like that. Okay. Now I measured this plate before, and I was surprised that it was real close. So 506, so it's only 6 thousandths oversize, which is, I don't know, pretty good for heavy material like that. So and I'm just going to use a pointer here to pick up that scribe line. I know this is not an important surface. This was transferred off of the center line of the circle. So that's the one I kind of care about. I want to use that as my master reference. Okay, so look at right there. Go ahead and zero it. You know, these are just flame cut edges that don't really matter. So just for shits and grins here, I think that was 2 inches. Is what 2 inches. Let's check it. And that looks, once again, it's the old flame. Yeah, that's pretty good. You get on the kind of the average spot, yeah. Okay. So yeah, we can just start smacking a hole through that. This is just a regular 90-degree spotting drill here, just to give me a good, nice, good tight spot there. And this is just, I don't really care, just to get a hole started. going to drop this puppy down. Get this chuck out of here. I get this 1732 drill here. Oops. Oh, 9/16 column. What the hell size column is that? 530. All right, that's a silly size. What the hell did I use on that? I must have used this one. I've used this drill before. I'm using this because it's a taper length drill, so it's nice and long, but not too long. You know, it's one of those kind of one of those deals. Oh yeah, that'll work. Getting back here now. So I'm at the bottom of the pilot hole. Now the work is alrighty. So we're going to drill and tap in the end of this 7/8 20 to accept this bronze nut in here. This bronze nut needs about 3/4 of an inch of good threads to sink it in there. So I need to drill it a little deeper than what I need on the threads for clearance for the tip of the tap to go through there, and so that I can get a full 3/4 of an inch of thread. So what I do, just so I know how much farther I need to go, is I just look at the last or the first kind of fully formed thread there, and if I set 3/4 of an inch on that, roughly, so the bottom of the tap, I need 1 1/8 of good hole to get that much thread in. So that's just a quick way to kind of do that. So I need 3/4 of an inch of good threads. I look at the first fully formed thread on there and just set that there. Yep, about 1 1/8 on this. And now that's 1.1/8 at the full diameter, not from the tip. So we'll go through that too and set that also. So okay, this is definitely back gears. So what I'm going to look for is when this is full diameter here. And you can feel the edge of the hole. The edge of the hole, it's got straight walls on it now, and you can actually feel that with your finger. So I'm right there now. I'm right there now. So what I'll do is I'll set that back in the hole, and then I'm going to zero that pup right there. And now I can just drill down and read my depth directly, and I know that that's this diameter. Now, this is kind of a weird thread, 7/8 20, so I don't have a drill that drills it direct, so we'll have to bore that also. So. And you see that I'm kind of short pecking it there. That's so my chips end up short like this, and they're easier to control and pick up after the fact instead of these really long stringy ones. So if you kind of short peg, you get these better, easier to control chips. All right, that's 1 inch. All right. Okay. Get that out of there. All right, so we're going to put the boring head in here, and this is a Criterion DBL 203. You know, this is a kind of a standard shop boring head, and we're going to use a Criterion boring bar that has a nice little insert that goes in it too. These are pretty nice. Couple of things on boring heads. You hear a lot of stuff about these locking screws and you know, different things. My opinion, and I've had good results with this for many years, is once I set the tension of these clamping screws, so I have some friction on the head, I just leave them alone. I don't loosen them and tighten them and mess around with them. I get it to a point where the thing moves freely when I drive it, and then it stays put when I'm not driving it. it's well engaged. There's nothing that really makes it want to fling out of adjustment. And I've bored plenty of good holes by not screwing around with those. Some guys like to loosen them and tighten them and secure it. They just feel they feel more comfortable that way, and that's fine. You can do it that way. I just don't like to fuss around with them myself. And I found I've gotten good results not messing with them. And it's just one more step. All this work has a zillion steps to it anyway, right? Why do we need to add more, right? If it's not necessary. That's just my opinion. So do what works for you, obviously. So if you're more comfortable, or you're running your boring heads at 10,000 RPM or something like that, then by all means lock the screws down. All right, so looks like we're going to be in the center hole here without too much trouble. So I want to bottom that out and then feel that flat on this and then lock that down. So what I'm doing is I'm just advancing the boring head a little bit and then probing that hole. Should probably lock the table there, just for fun. Alright, so it looks like it's just scratching that hole. And then what I want to do is I'm going to end up on a nice even number. There we go, something like that, a few more thousandths. I know I got a little bit to come out of the hole, so I'm not too worried about taking too much there. Okay, so what I'm going to do is I'm just going to move off of it for a sec, and I'm going to zero my tool right there with my quill readout, and I'll move back into position. 3, there you go, like that. There. And now I can go to the bottom of the hole, yeah, and I'll be just dandy. We're going to go ahead and set the quill stop while we're at it here. And they have a little quick one that has a push button on it. I haven't put one of those on here yet. Eventually I will. It's kind of a low priority. We're going to use the power feed here to bore this. Okay, so I'm sitting in the bottom of the hole right now, right there, and then I'm going to run this up and run it just off of the bottom of the hole, right about like that. Okay, okay, let's get some speed set here. Sure, why not? Now you noticed I went ahead and just engaged that feed without turning it off. When you're on slow speeds like that, it's not grinding at all when I go in there, so it's okay. And I think I want to increase that feed rate. That looks better. Alright, so let's get close to the edge of the hole, and I use a little quill tension there just because, keep things from bouncing around, and there she goes. It's just taking a light cut. So what we're doing is we're calibrating that surface now. So we're in position, X and Y, and we're just taking a skim on that hole, and we'll get a measurement, and now we'll be calibrated, so we kind of know where we are. I'm going to grab some measuring gear here. deeper than that. All right. Finish feels good. Let's get a prelim measurement here. And I like telescoping gauges. They're just pretty foolproof and easy to use. And you can reach past the boring tool real easily. So I'm just going to check it with calipers to start with until I get close. All right, so I'm 786 right now, and I want 826. So 90. And oh yeah, not very far. 20. So I'm going to take 26 thousandths, or I'll do 25 thousandths. 10, 25, and that puts me right on 0 too, which is kind of sweet. Get close to the hole. This one reads 1 division is 1/1000th, which is kind of nice. So. And my chip's coming out of the bottom, which is good, so it's not packing in the hole. And remember, this hole is it's just a tap drill hole for our 7/8/20. So it's not like a bearing bore or something like that. So I'm at 810 right now. So I need another 16 thousandths on that hole. I just dialed in the 16. Get down there. I'm gonna add a little bit to my my depth and engage. Some of you might wonder why I use this air in a can stuff here. It's not because I don't have a compressor. I just don't have a really nice compressor, and it makes a lot of noise, and I have to think of the other folks that are in here right now and noise, so I like to keep things a little quiet. Anyway, so that's the reason. There's nothing special about it. It's just convenient, and it's not very noisy. All right. Okay, 826. Perfect. Okay. All right, so let's get this down. Put that down. And yeah, you know, I got some more holes to bore later on. I think I'm going to leave the bar in there for the next go around. I want to dink that insert. Oop. Let's get that out of there. All right, Mr. Wizard, here, cooperate. So I kind of just left that set. So I know I'm close when I have to do the other holes. So this is just a point. It's a busted end mill that I just put a 60-degree point on. Nice hard steel, and it's got a little center in it too. Alright, well that's where you earn your money here. So, you know, some guys use spring-loaded centers here, and that's all fine and dandy, but most of them that I've seen are kind of wobbly. Unless they're fitted up really, really well. They're kind of wobbly, so I just use kind of a dead center. Hard against hard makes a nice bearing, and I just take the quill down to keep things straight. I have a couple of those, and the ones I have are kind of wobbly. I didn't make them, but I picked them up somewhere. So maybe that's why, is I have wobbly ones, so I tend not to use those. The spring-loaded guys. So I'm just, you know, putting some pressure down on the quill and keeping it engaged with that tap. And this is a good reason for, you know, this is a big thread, right? So nice fine threads. The threads aren't very deep, so you know, I can turn that with one hand without fighting it. This is a 3-flute spiral point, so I don't really need to back it. You can see the chips coming out of here are continuous. Now I'm just going to go till she stops. Okay, that's it. That's the bottom of the hole. Now you want to be careful when you're coming out of the hole because the weight of the tap wrench can take your tap sideways on you and kind of monkey bozo up the edge of that hole. So I take it off and then just take it out that last little bit by hand. So, well, see what happens here. I think I gotta get a tool here.
In San Francisco, 98.5 in San Jose, K-Fox.
And kadunk, there it is. Down all the way. And then our lead screw. Our lead screw goes down through that, goes all the way through that. So I got this nice hard bronze on this hardened screw, kind of. Okay. So. So typical machinists, when left to their own devices, they generally make threads tighter than they need to be, just cause we can. That's the chip. Okay, so I'll just smack a little chamfer on the edge of that hole and call it done.
This weekend, check out the 37th annual San Francisco Free Food Festival. It's at the Presidio Middle School in the city, up in Nevada today. It's the Nevada Pop and Break Festival. It features radio playing some music. The for the ultimate tribute to the Beatles tonight at the Uptown Theater in Napa. If you're looking for some movies, how about Ghostbusters? It's playing at the new Parkside Theater in Oakland. And
Alright, here's our next setup here. We're going to cut a groove here through this, 1.5 inches wide, about 300 deep, and actually both sides, so it's going to be something like that. Down to here, something like that. So what I want is that groove to be perpendicular to these surfaces here. So I'm just going to throw an indicator on that and make sure it's kind of straight. So what, 6 thousandths? Oh, less than that. Which way are we going here? It's going away. 5,000. It's going in. Oh yeah, there we go. One more sweep. Okay, I'm happy. I'm gonna put a little more meat on that. My little handle can do. Well, I don't like that. Looks like this is, it's up. You know what? We gotta run an indicator around this a little bit and see if we can. Doesn't do any good if you're not straight both ways. Yeah, don't do that. Don't do that, Mr. Wizard. This little handle's sticking down. Let's do that. Put it on top. Oh yeah. Okay, so we've got some more business there. This might not be the best. In fact, you know what? This is a crap setup here. It's convenient because I don't have to take the vise off, but what I really want to do is I want to lay this on the table so I have a nice broad surface to work with. So I'm just going to go ahead and do that. I thought I could save a little bit of time there, but the indicator doesn't lie, so let's get that out of here. Doesn't lie. No, I think I'll use this as my reference surface here, and I'll just pin this straight down to the table, and just do my work right here.